Hello everyone, welcome back to this Shanghai Tower Grasshopper tutorial. In the previous part, we finished our base profile for our tower, as you can see here. So we output them into these two components so that we can easily copy and then use them further on down the script. It's basically the center point and the base profile. What I've done is to give these two a name. We call this parameters, and then here's where we add all of each parameters, and we grouped our script, and I'll just call it the base profile. But you can call it anything you want, which makes sense to you. I would give a tip for organizing your script will be try to group them, your script components that makes up a certain function or does a certain things as you make your script. This way, when you come back the next day, the next week, or the month after, you will immediately get a better sense of what you've been doing, what you've done, and you can pick up easier in that way. So that's my tip and my advice. Start organizing in the beginning as you make your script. I mean, if you're going to do it one session, then yes, you can decide for yourself if you want to do it within that same session, or you just do it at the end of the day. But that's up to you. But try to keep them as grouped, as organized as possible. It will help you in the long run. So with that being said, what I will show you right now is the part that we will be focusing on. Let me bring that back up. So this is the script that I've made prior to this. And what we'll be focusing on is basically this part of the script right now, as you can see on the screen. Let's briefly talk about the output that we hope to achieve at the end of this part, or at the end of this tutorial. Is what we want is have the curve ready for our core. As you can see, this is a stepped core, and what I mean by that, if I turn on select view, you can see that it gets smaller as you go higher. It's a stepped core, and here we can have all the radii for every core that we made, which are like these circles. So those curves basically makes up this stepped core. Now, the next thing what we want to achieve is generally have the outline of our main tower as a geometry, and we don't, these are just purely for preview so that we can actually see them a lot better, and then we can check out our panels when we get to that part if they align well with what we have here. But importantly is the curves that we're going to be using further down the script. And if I enable this, basically per floor, every outline where there should be, like rotated and scaled a little bit, because as you go up, the tower gets smaller. That's one. And then we have this one, there's the surface floor, and these are the blocks that divides between the zone. It encompasses 2 floors each, and what we have in here is a number which signifies the floor number of where these surface blocks should be. Now, in the beginning, let me look at the end. We see will be making a couple of parameters for this part to work, and in the middle is what drives this whole thing. And I added a bit of what do you say, customization parameters, so you can customize your script. For example, if let's see this one, let me make a new copy just to show you. Let me unlock it, and then I'm gonna copy, put this one here. So if I change this, you see that the distribution of the surface floor changes according to my curve. But if you don't want that, and you want it linearly, you just leave it like this. So this is among one of the few things, should probably connect that back. These are among the very few things that we are going to be exploring in this part. So with that out of the way, let's get back to our own script and continue on from here. All right, so let's start giving our tower some 3-dimensionality. Not even sure if that's a word, but what we want to do is, let's start with, well, obviously we need some parameters, but we can start extruding or getting the curve of our base profile into the floors that we will have. So we'll just copy this, and I'm gonna give this a new name. I'm gonna call it, oops, that's not the place where I want them to go. I'm just gonna call this floors. There we go. I believe we have 128 floors in total. So I'm just gonna give this a quick rename. I'm gonna copy that again because how high is each floor? So floor height, I'm gonna quickly modify this. I'll give it a minimum of 3 meters to 8 meters. And then between, I think I measured about 495, something like that. But obviously you can change that however you want. If you have slight OCD, you can also change that to 5,000. Makes no really big difference. That's 50 mil. So I'm just gonna quickly, what I'm doing here is I want to use this in the area here. So I'm just gonna quickly Control X to cut it, and then Control Shift V to paste that in the center of my canvas. I'm gonna do the same for these. So I'm just gonna copy this quickly and then just say, yep, I'm gonna make you hidden so I don't see it. I'm just gonna put that here. Now with these parameters, what we can already do is to start giving this dimension. So obviously we need a move in the z-axis, so I can just copy this, plug that in there, and we want to move them by the each floor by the floor height. So we can do a series starting from 0. That's fine. The step, well, the step is the floor height obviously, and how many? This amount of floor. So if you make a panel, you can sort of visualize what we have here. So the maximum goes to about 632 meters, close enough. We'll get there. All right, with that said, you can just plug this in, and if you want to start with the curve, then you have the curve. And the same thing also we need to do for the point, or you can just plug in area here, which more or less does the same thing, but I prefer to work with this one because the data is, this one is precisely in the center. And if I do an area, sometimes the area will take, will give you a different point based on the geometry where you want the area of. So this is just to play it safe. Even though the shape's the same, so the center point is going to be the same, but it can be shifted when compared to this original point. But anyway, I've used this for every 2 points, each of these 2 components. I can actually plug this, shut this off, and now what we want to do is we want to scale it. We want to scale our floors because the higher it goes, the smaller each floor gets. So the components we want to scale, the geometry we want to scale is obviously G. We can shut this off. The center point, well, those are the center point, right? At this point in time, the data tree structure should be aligned perfectly, so I don't need to worry too much about grafting and flattening stuff. They will be the same as long as they come from the same components. So that's still, now the scaling factor, this is the part where we're going to talk about how much do they scale, right? So what I've done is we might need a new parameter. So I'm just gonna quickly, let me take that one. Doesn't really matter which one you take actually. And I want to define a scale when you reach the very top. So I'm just gonna call it, let's see, scale at top, scale factor. I'll just call it top scale factor. That sounds a little bit more sensible. So I'm just going to put it here. Now the scale factor has to be from 1 to 0 to 1 and anything in between. So I'm just going to make that into a 2 decimal number where the minimum is 0, maximum 1. And I'm going to start with 0.5. 0.55. I think it's the sort of factor that I also measured before all this. I'm going to do the same exercise for this. I'm just going to copy, not copy, Control X, Control Shift V. I'm going to have it here. Oops. Accidentally triggered something over there. Now, what we can do with this is we can start playing how much we want to scale. We can introduce, apparently I did not. Wait, let me double check. Am I doing this right? Yes, I am. Okay. So what we can do with the scaling factor is at the top we define this scale factor, which is 0.55, and the bottom is going to be 0. And for each floor, we're going to have them scale either linearly or not linearly by using a graph mapper, so that we can control if we want to have it scale linearly or not. And well, you can just basically play around with that part. So to make a list of scaling factors, what we can do is instead of series, we're going to use range. Because range takes in the domain, 0 to 1 in this case, we're going to change that and the number of steps you want between within the domain. So we have a 0.55 scaling factor. What we can do is we can create a domain. I can just do, domain construct domain. So this one is 0. We want this to be, let's see, it should be from 1. We're going to modify that to 2. And what we're going to have here is we're going to have a domain that's 1 to 55. We can plug that into the domain. The number of steps we want is obviously the same number of that we have of how many floors we have, so we can scale them accordingly. Because we have 128, we will have, how many do we have? 129. So we need to cut down one number from this in order for the scaling factor to work. So I'm just going to come in here into the steps. I'm going to do an expression. I'm going to say x minus 1. So that gives you 127 and outputs you 128 values for the domains. Now you can just plug this in here and it will work. But this is very linearly, and we mentioned that we want to have the option to adjust the scaling. So we can plug that instead into our graph mapper and right click on the graph. You can go to graph types. We can start with let's say Bezier. Now if you plug this now to here, you won't see much change because, well, this is a straight curve. It's the same as being linear. But if you start changing this, you'll see that the tower has different shapes. This, you can even create something like this, or you can choose different. I think I like the power graph because there's less handle to change. So yes, with this you can change. I mean, you probably don't want to go all the way like that because then you're going to mess up your entire script. But I'm going to leave it at default for now, maybe ever so slightly down to the bottom, just to give it a sort of like a curve to it. So now we have this, and the next thing what we can do is we can start scaling each floor, rotating each floor by using a rotate. The object to rotate is obviously that one, so we can actually hide this one for now. And we're gonna kick this into a degrees. Now, to rotate in degrees, the amount of rotation that we need, well, that's based on the new parameters we're gonna create, which is the twist angle. So I'm just gonna call this twist angle. And like I've said in the spoiler, in the preview for tutorial, not the preview tutorial, the intro video, the total twist that they utilized is 120. So let me quickly adjust this to 1, or it doesn't really matter actually. So I'm going to copy that name here. We are going to make the same exercise. So I'm just going to do this. Control Shift V. And we're basically going to do the same exercise here. We will have another graph like this in order to control the rotation as it go up. So we can start by actually just copying this. Now the twist angle, let me put in a panel so we can see what we're doing. The twist angle is 0 means no twist, right? And remember we've modified this, so we want to modify this back to 0, so that domain goes from 0 to 120. And if I put this in here, you get number that goes from 0 all the way to 120. And with this, we can now plug it into RA. There we go. So if I enable that, this is a straight tower, and after rotation, we get this. Pretty neat. Oh wait, I think I mentioned that we might not need a graph model. I mean, you can. Well, no, let's not do that. I don't think we need to change it. I mean, if you want to, you can obviously, but you do have to keep in mind that the standard graph goes from 0 to 1. So you might have to use a numbers remapping, remap numbers to remap these over one integer into the domain of 0 to 1 instead of this domain. Okay, so now we have that. We can look into, let's see, maybe the core. Actually, before we get to the core, let's visualize this for ourselves. So we're going to do a small loft of our curves. So we're going to put this in here. And we're going to do a preview. Yeah. You can actually hide this one now. We can make a swatch, color swatch, and then we can plug that into the M. And then we can give this a nice different color. So just a hue. I think we'll give it a blue since the tower itself is quite blue-ish. Oh, glass is blue. Change the opacity down. Opacity? Yeah, we can change the opacity down a bit. Give the lightness even. So we have this nice outline that we can sort of motivate ourselves to continue on. And while we're here, what we can do is let's output these lines, because we will need these lines later on in other script, in other part of the tutorial. So we're going to call these outer wall curves. Oops, outer wall curves. There we go. And we can actually hide that because we don't really need to see it. We'll move that all the way there because we probably need some small space. All right. So with that said, we can actually now really move on to the core. The first thing we're going to do is identify where we want the zone to split. So needless to say, we're going to need to create new parameters. So I'm just going to come in here, copy this one. I'm just going to call this zones. Very descriptive. We have 9 zones. Oh, why is that? 9. Let's say we will have a total of 20, something like that, a minimum of 3. So we can plug that in here. Also, what we want to define is where this where's the first surface block start, with the first zone ends basically, and where does the last one start. So we're gonna create those quickly. Also, I'm gonna get a copy of this one. Actually, I'm gonna create 2 copies. First one, I'm going to call this zone 1 start. Oh, zone 1 start. But actually, zone 1 end is where they end because it started 0. Zone 9. I wonder why my mouse always goes to that side. Zone 9 start. I believe zone 1. Let's take a quick look. Let's set it to 5 or something like that. And then the zone start. Well, we have 28 floors, maybe 110. Let me create this here. Did I copy zone? I'm not sure if I copied that before. Oops. We'll do the same thing. Actually, to make this easier for us to copy, no, that's fine. Or do it like this, like this, like this, so we can just Control X and move all the way into here. Okay. What we've done here is also setting up the preparation for the other part, which is making the surface blocks, the surface floors. But we'll focus on the core first to get those curves out of the way, or to extract the curves so that we can have the core. One thing we want to do identify first is where to start, where to end. So hence these two parameters that we created, zone 1 and zone 9, zone N and zone 9 start, so that we can start by making a domain construct. So we're going to construct a domain that goes from these two, like that, 5 to that. That should be okay. And we have the total number of zones, 9 zones. So we want to create where we have the start and the end, and whatever is in between is we're going to try to populate it with this. Let's try a range with the range, so that we don't have to go guess. Oh, hey, let's put zone 3 starting from floor X and Y. You know. Takes a lot of the guesswork out of here. Is basically what I want to say. So we're going to plug these two in here, like that. What do we have? Actually, I might have to replug this somewhere else, because from these number we can tell linearly, zone 3 will be this one. We'll start at floor 28, according to this. So that's one thing we can go about this. And okay, let's work with this. First off, let's try to round this. So we're gonna go round numbers, and let's try the nearest number. I mean, that makes more sense. And you can take any of the other two, doesn't really matter as much. So now that we have these numbers, I think it's a little bit too much. Wait, I should have excluding zone 1 and 9, I should have 7 zones. So I should have 8 here actually. I might have to call off, because we have zone 1 already and we have 9. That one ends at this part. So in the end, we want a total of 9 zones, which a total of 9 starting floors. That makes sense. But we have here 10. You can actually call maybe 1 or 2 away. So I'm just gonna come back here and start doing that for now. We might have to do 2. I'm not sure yet. So this gives us 9 starting zones. So we'll leave that as is. Okay. With that said, what we're gonna do is we want them to be 2 blocks. Or actually, we can start visualizing it this way. What are these again? Oh yeah, those lines. What are these again? And you can plug that in here and you can see what we've selected. Oh, one nice thing what we can do now is actually check our front view. And you can see that our retail is not actually there. It's actually a lot higher. We want this line to be in the middle, because remember, we want to have 2 zones, 2 floors as a block, unless you want more, but we can make that into a parameter so you can set later on if you want thicker surface floors. So let's go all the way here. Let's try 7. Well, 7 sits about in the middle of it, so I would say that's about right. And zone 2 is also fine. See, zone 3 is a little bit off, zone 4 also, and we're gonna have a lot of problem there. Ooh, wait a minute. Zone 9 is all the way there. So what is that? Is that 113? Actually, I say zone start, so it should be there. I might have to dial this back down. 110 is actually a good number because it's in the middle of it. And we're gonna plus 1 and minus 1, so it should be in the middle. Oh, and then we have the crown floors. We'll look at those later. But anyway, all the zone in between. Let's see if we are having the correct one. So that's one. Let me select it so that you can actually have some green line to see. So that's one. This will be for this one. This will be for that one. This will be for this one. This line for this one. This line for this one. This line, yeah. So we have an extra line that we have to call, even though we already deleted one. So I'm just going to come in here and do a -2. And we can see all the lines are a little bit closer to what they should be, but they're not exactly that. But we can fix that because this is, remember, linearly distributed, right? So one way we can fix that is we try a remapping of numbers. Let's see, where should we start remapping these numbers? Let me try, let's try this first, because let's not put in a domain. Actually, do I need a domain for that? 0 to 1, okay. That should be fine. So I want to remap these numbers. Oh, I do need a graph editor, otherwise it makes no sense to remap these numbers. So I'm just gonna quickly jot this down so it's easy to see. So those are those numbers. So I'm gonna remap the values. Well, the source is the same, so I don't need to do anything about that. But the domain I want to remap to this one, and we'll get something like that. And then we can now plug that one there. I can delete this one. So watch what happens if I change the curve on this one. You see how the middle pack sort of like shifts up and down? So what you can do here, oh, I think I already got a magic numbers because all the lines sort of like sits within that zone there. So what you can do here now is you can play with this and then to get a nice distribution of floors for your design, or you just go to default and it will be linear, and then it will be as if this one doesn't exist anyhow. So that's I would say that's up to you. What I want to do also while I'm here is I want to create some sort of like override. For example, let's say you want to modify, you want to keep every floor as is, but you want to modify the third block or something, this 49. You want to change it to, I don't know, 55 or something like that. I want you to have the ability to do that. So we're going to create an override, a manual override, so that we can switch between let the computer do it, let the script do it, or based on a graph, or we come in and modify those for ourselves. So let's start with, I'm gonna quickly pull this out just for now because I have a feeling we might need it. So this is an indication of what floors you'll get when you let the script do it. So what I'm going to do is create that quickly. I'm going to copy the data from this one. Obviously, I don't want this to be connected anymore. I'm just going to quickly paste that data, make that into a multi-line. So I'm just going to call this, let's give it a floor manual override. There we go. And we want to have a toggle at the toggle that is called the same thing, and we're not. There we go. And then we can do a filter stream. Filter. Is that how you write filter? And what this filter stream does is based on this toggle. So if I do it here, now it says floor override manual false, meaning everything that goes in 0 will come out of 0. But if I toggle, it will come out of 1. So we're gonna quickly, let's do this one also here, and then we plug this to 1 because that's when the override is set to true. Let me delete that one. And as for the other one, we're gonna put everything here and control that here. All right. So this is just for an indication of what numbers give you, what the script gives you. And let's say you want to override it. We can turn this on, and you can write this 49 to 55. I'm not sure what 55 is. I think it's this one, seeing as this one is not out of bounds. So if I put that back to, it was, what was it, 49? It should jump back in to place. Oh, should not have pressed enter. Should just click away. There we go. Similarly, we can also do for, I'm not sure if we can do it for the top floor, because that's governed by a different script. Oh, actually, you can. So let's say we want the top floor to, oh, that's out of bounds, we can't see it. So let's say you want the top floor to end a little bit higher. Let's say add 5 floors to it. It'll stop there. So let's turn the override off. I'm gonna quickly copy this and paste that here. Oops, I think I copied it twice. We'll save that. So that gives us the flexibility to change if we want it to change. Now that we have the floor selected, the next thing we want to do is to select the floor above and the floor below so that we can have 2 floors that belongs to the same block. A very easy way to do that is just to add 1 and subtract 1 from the indices, because these are indices what we see here. So let me see, actually we're gonna go in here. Well, let's make a new one. Since I am not gonna modify the amount of surface floor we have per amount of floors we have per surface block, I'll just leave this as 1, hard code it into a panel, and then I'm gonna put in here, I'm gonna put this into the B so that I can have the number you have plus 1, oh, plus this one, and the number we have minus 1, so that you will see that we'll have in the end 3 integers. So it's 8, 7, and this will start at 6. So 6, 7, 8 is going to be the starting floors, which encompasses the block that we need. All right, so with that said, we can merge these together. I might need to graph something. Well, let's wait, what is it? Oh yeah, so remember that we have, let's start with the lowest first, then the middle, then the highest. So if I quickly hide these, because it doesn't really matter, what you see here is something quite messy, in the sense that they're not really organized in the same way we want. What we want is each 3 of these floors should be in a branch that correspond to the zone, the block that they should be in. One easy way to do that is if we were to graph, should I graph here? I can graph there. Yeah, so if you graph that, you can see clearly already the results that we wanted. So block 1, 6, 7, 8, right? And if you plug that into, let's say, this one, you get the floors nice. Let me delete that. Sorted out for us. And now, let's go back here. Oh, that is a quite nice shape. So if I were to loft this, wait, yeah, you can loft this. So if I loft this, where we accidentally made the service blocks instead of the core, but doesn't really matter. It's the same thing. We have to do them both anyways. These are open curves, open poly surfaces. What we want to do is we want to cap them, just to make sure that they are a solid. So we're gonna just do a normal cap. We're gonna copy that part and we'll plug it in there. We're not gonna give it the same blue. We're gonna give it purple-ish, like that. Can delete that. We don't need that anymore. And what we can now do is also export these numbers. These are surface floor numbers, and we're going to call this surface floors. There we go. This one, well, let's flatten this because it's just for us to visualize it. So now we should have something similar or actually you should have something similar as on my screen. Now we should really go back and focus on the code because that's the last thing left. I doubt that we will accidentally wander into something else, which I obviously hope that we don't. The concept for making the core is, let me try to explain that with my trusty Epic Pen. What I want to do is, you have these service blocks already. We have the integer where the blocks begins, or where it, at the bottom of it basically. So what we can do with that, we take that integer, we make our floor, our circle, we extrude that down to the level below it. And this one's obviously going to be a little bit bigger, so like that. There's one problem though. We don't have any surface block at the top, but we do know there is going to be another core here before it reaches that crown on the top. So we need to introduce a new parameter so that we can have that number at the top. And let me clear everything and delete that. So we're going to do just that. We're going to create a new parameter. We have here start, and what we want to do now is to say how many floors do we want to give to the crown in the end. So I guess this will be crown floors. Now let's start with 8. We don't need all this. I'm just gonna limit this to 20. So that's the crown floors. So I'm just gonna quickly do this again. We might have to, at a certain point, come down here and make all these so that we can quickly drag them or copy them away. Or actually, if I copy this and Control Shift V, oh, it does do that. Okay, okay. Maybe we should do that now that we're already doing this part. So what I'm gonna do is just copy this one like this. We're gonna quickly adjust each and every one of these and just move around to make sure that we have, so that one was not properly connected. And what we can do is set these to hidden, so that when we copy them, they'll already be hidden, so we don't need to click these all the way. So like this, or we, instead of what we've been doing is Control X, we can do Control C, and we go all the way where we wanted to use it. We go Control Shift V. We have that. Now if you trace back the wire, it will be from the original one. So this is just going to be a placeholder for us to easily copy our parameters to use. So coming back here, we have the crown floors, which is, I don't know even how many is this? 8. All right. So what we can do is subtract 8 from the top. So we're going to do a subtraction. Subtract. We're going to subtract the amount of floor that we have, which is the top, and then we get 120. So with that said, what we can do now is, if we do a list item, that one, yeah, we have these floors. We can plug this in here, and if we take the upper, or actually, since we're already here, we can do, no, yeah, let's take it from here. It doesn't really matter, because we're thinking like maybe if we take a list and reverse the list, we'll always have the last number here, but this one works just as fine. Yes, if I do this, it will be from the top. Oh, actually, we need it from the bottom. My bad, sorry. And as you can see, we're missing the very top one, so we need to add that in here. So we can do an insert items, and what we want to insert is, if I put this list all the way here, I think I might have to even flatten this first, but we'll see. I can actually flatten this here, and let me put up a panel so we can see what we're doing. I put on another panel that comes from this one, although this one is not flattened, but you should get the idea. Or to do it well, we're gonna put this in here, we're gonna put you there and flatten it on that part so that you can see what's going on. So in the end, what we want to do, we just want to insert one extra number in here, that is the very top one, which is obviously this one that we made. So that's why we use an insert. So we have a item to insert. Well, we want to insert this one, please. The index we want to insert. Here's a trick. To avoid, there's two things you can do. You can do a list length like this, and then you put the list length in here, so that you always have the number. Actually, looking at this, I might even go with this. But what I've done in the previous script was, if this is not your preferred way of working, what you can do is you set this to 0, right? It will be at the top, but if you rotate reverse the top list first, and then you reverse it back, you essentially get the same thing with one less component. Although I can understand that this might be a little bit confusing for some, but as you can see, it achieves the same results, and it's just as quick. So it's purely up to you which one you find more logical in your own way. So I'm just gonna use this one instead because it's less component. It makes it a little bit more clean, but that's the idea behind it. So now if we put this in here, you see that we get an extra circle. We should then get extra circle at the top. Now, what's the point of all this? Now that we have those selected, we can safely say, all right, this is where the floors will extrude down, like the sketch that I made just now. So I'm going to keep this here. And coincidentally, we can also use these new vertices to select our points, which is this one. So if I do this one here, oh, those are not points. Oh, wait, I did this wrongly. I want that here, and I want the index here. There we go. So if I switch quickly to my front, I can see that the points are where they should be on the same circle, same curve. And the idea of this is now if I do a point closest to the curve, which is this one, curve closest point, and I select my C curve. And what we've essentially done in here is we calculated the distance between the center point of these to the nearest point on our curve. And what we can do with that is, because the curve is not, the core is not all the way to the edges of our base curve. It has a slight offset to the inside, and that's what we want to do, is where we're going to introduce yet another new parameters, which actually is a parameter you might not change that often. So now I'm actually thinking in my head, if I really want to make it into a global parameter, just make it into local. Let's try local first. Let's try with 2 meters. Let's say the core at the nearest point is 2 meters away, set away from the facade. So I'm just going to call this core offsets inwards. I think this is scripted enough. And we're going to make a circle, and we're going to make this one. Now, the P is the point or the plane, I believe. So which is, well, our points. Oh, not this one actually. This one. And then we can do a subtraction. Yeah, let's do a subtraction. So we can subtract this. What we want to subtract is the number we have here, just goes to A, subtracted by the 2000. And then that one goes to the radii. Because let me show you first, if I don't subtract that, you get, let me zoom into the very top one. You see how the circle almost neatly fit within that base profile. But if you do a subtraction, an offset, you get something like this. So now you can actually come in here and play with, if you want, you can do it like 5 meters away from the facade or that. So I leave it up to you whether you want to make this into a global parameter or not. I myself don't see that as necessary, because the shape, this size, is already driven by our scaling factor, which is 0.55 to the top, or our rotation. So I'm just going to leave that here for now. And I'm going to hide all this. I don't need this anymore. So now we have a circle. What we can do with the circle is we can actually now make that into a boundary surface so that when we go ahead and extrude this, it will become a closed solid. Oops, let me turn that back off. All right, now we want to extrude this. So let's get that here. Might have to move these all the way a little bit there. We can already know we want to extrude that in the -z. So we're just going to do here. Actually, I'm going to put in here instead. I'm going to say -z. Let's put in an example. Let's say 500, 5,000, 5 meters. So these will extrude. Oops, apparently that's not enough. So let's say 10 meters for visualization's sake. So these will extract down, right? And on each and every floor, we can see like, okay, the value has to be different. We can do the same trick here as we done for the insert. We will take, let me copy the list from here, and we're gonna move this a little bit here so you can see better. So we want the bottom or the top curve actually. So we're gonna take the plus, right? The same is we need a 0 here because we want these to, oh, well, where is my model? There we go. We want these to count down to the digit that they hit, the floor that they hit, basically top floor. Because if I do a list item from our floors using the top, you'll see that we get this one, we get that one, but we don't have the very bottom one. So we basically doing the same exercise as the insert here. This one is a lot easier in the sense that we know the bottom floor is, well, it's 0, right? So we can just set this here. Actually, let me put this here in case our tower is not beginning at 0. So I'm going to set this here so that you know that this is something we've hard-coded in. Okay. This time we're not going to take, we're going to just copy that one. This one we're going to take this one instead, the plus. We will not be doing any reverse in this list. So now what you see is if I quickly show this here, there's a 0 now. So if I put it in here, you see that we selected the bottom of every surface floor. So we can use this information to calculate how much we need to extrude back down. Now we have this list, and we have also the list I believe, which is, where is it again? This one, yes. So the math is we do 6 minus that times the floor height, and that will give it the extrude that we need. So we're going to use an evaluate because there's a little bit more involved than just a simple multiplication, extraction, or any of that arithmetic operation. So we do an evaluate. So like we said, we want this one, right? Let me add one more. Subtract, which was it? Was it this one? Yeah. We want to subtract this one by the, and then multiply the number in floor height, which is that one. So I'm just going to quickly drag it here. I'm going to put this here, and then I'm going to open up our expression editor. So we can say x minus y, right? Put that in parentheses, times the floor height, which is z. So we get these numbers. So now, if all goes well, we can plug this in here, and we have our extrusion. That's based on how high each zone should be. Something you might have noticed is this is different than what I've shown you in my previous script because this one excludes the surface floor. There's one simple way to do that. If you want to include the surface floor as well, then you just use this instead of the top floors. So let's see if I do this. Oops, where are they? This one? Yeah. You see that it's now going through the surface floor. So it's a matter of which one you want. It doesn't really matter which one, to be honest. if you're going to use this for rendering, or yeah, if you want to use it for rendering, you don't want overlapping features, so you might want to use this one instead of the other one. But if you want to do calculation of how much volume is in the core, then I can imagine in that case you then want this number. So I'm just gonna I'm gonna leave it here. You can choose which one you want. So now we have that part. We can now do the same exercise as this one. Whoops. And plug that in here, and we call the core, give it a different color. Well, the core, we can just a little bit light gray like that. At this point, we can turn off the base. So now we have the nice, pretty core. I can see there's a line somewhere enabled. Does that come from here? I'm not sure actually. Oh, that's from this. Of course, yeah. This line comes from the one at top. So in the end, you might still want to do this, if that bothers you. But in my case, it does bother me a little bit, slight of OCD-ish. Even though this overlapping features also bother me a lot. But in the end, if you want, you can actually merge, join these two together, and then you get the same. You get those out of the way. But I might want to be using this for render, so I want to keep it as separate elements. So I'm just going to keep it as is. Also, one thing, we're almost there. One thing we're missing now, we can actually, the radii that we've used for our core might be interesting for us. So what I'm going to do is I'm going to output that into a parameter so we can easily copy that in our next scripts. I believe, where's the radii? Should be this one. Yeah, it's this one. Should we round this number? Why not? There's no point in using such a weird number in this case. So I'm going to round you to your nearest number. And I'm going to call you core inner radii, in case we wanted to use it somewhere. I don't know where, but we might use it. So I'm just going to, or, well, might want to spread this out a little bit. Anyway, something like this. I'll give you the time of the world to organize this yourselves, but a little slight OCD from my side. I want to make this a little bit neat before I end this part of the video. So I'm just gonna go like this and quickly like that. There we go. All right, I'll just save that. And wait, do I need this? Oh yeah, I do need this. So now I can actually come in here and just do Control G. I'm gonna copy this text, Control Shift V, and then I'm gonna call this a tower outlines, something like that. And then we're gonna add this to the group so that it moves with the group. All right. I think we'll stop it here for this tutorial, for this video. I think it's been quite long already. And in the next part, we're gonna be looking into the actual penalization. I think that part is probably gonna take a while. It's just also the most intensive part of the video, and we're gonna, I hope you have fun watching that one as much as I had fun, and a lot of hair pulling trying to get that right in the first few scripts that I wrote. So with that, I end this video, and I hope you learned something new, and we'll see you in the next one.